Welcome back, everybody. In prior video, we discussed linear equations and how to solve them. The key to a linear equation is that there's just one variable and a single answer. So for example, you could have like 2x plus 3 equals 5, and there's only one variable and there is a single answer. But what if you had something like x plus 3y equals -1. You then have two variables. You have x and y. And there is no way to solve this for a single answer if there's only one equation with two variables. If you have two variables, you have to have two equations. So for example, we can put in 2x minus y equals 5. And this is what we're going to learn how to solve today. Before we can discuss how to solve that type of equation, I want to talk about the answers. So for example, if I say something like, determine whether -3, 1, that would be x and y like an ordered pair, is a solution to the system x minus y equals -4, 2x plus 10y equals 4. All right, so the question is, I've given you a potential answer, -3, 1, and I need to see if it's a solution to the system. Now, you could solve the system, which we'll talk about a little bit later. But there is also a way to check your work. And the way to check your work is to plug in -3 for x, 1 for y, into both equations. Now, the key is they both have to work. All right, so for example, I'm going to do the first one. I have -3 minus 1, right? -3 in for x, 1 in for y. And that equals -4, and I have -4 here. That works. All right, so let's try the other one. So I have 2 times -3 plus 10 times 1 equals 4. 2 times -3 is -6, plus 10 equals +4. So what we see is -3, 1 makes both equations true statements. Therefore, you could say, yes, it is a solution. All right, so let's try another one quickly. Is 4, 2 a solution to the system? (2x minus 5y equals -2, 3x minus 4y equals 4. All right, so at this point, I'm going to ask you to pause the video. Take 4, you plug it in for x, 2, plug it in for y, and let's decide if it is indeed a solution to the system. All right, so hopefully you plugged it in, and you notice that 4, 2 is indeed a solution to the first equation. However, it is not for the second. 3 times 4 minus 4 times 2 equals 4. So 3 times 4 is, hang on. 12 minus 8 equals 4. So it is to the second, and let's see to the first. Now let's double check our work. All right, so 2 times 4 minus 5 times 2 equals -2. 2 times 4 is, okay, 2 times 4 is 8, plus 10, And that does not equal -2. So therefore, it is not to the first. My bad. All right. But either way, it was a solution to the second one, but not to the first one. All right. So not a solution to the system of equations. All right. So when you have a system of equations, there are three potential possibilities. For your answers. You could have one solution. You could have no solution. All right, so one solution means that the remember, linear equations graph as a line. So if the two lines cross once, then that particular point is common to both lines. There's one solution. If it's no solution, they never cross. And another word for that is parallel. And the third option is that there's infinitely many solutions. And in this case, it would be concurrent lines. Or coincident lines, which basically means that the two equations would be the same line. So all right, so there are our three options. The first method that we're going to talk about to solve an equation is called substitution. All right. And we'll go back to our equation that we started out with, that I said we would get back to later. I have x plus 3y equals -1 and 2x minus y equals 5. Now, substitution is ideal when you have a coefficient of 1 or -1. All right, so in this case, I have a coefficient of 1 for x. In the first equation, I'm going to call this one the first equation, this one the second equation. All right. And you could pick either one. Either I could solve for this x or I could solve for this y. Probably equally as easy to do with either one. So I'm going to take equation number 2 and solve for y. So I get y equals 2x minus 5. Right? And then now that I know what y equals, I can take that and I can plug it into the y in the first equation. So I have x plus 3 times 2x minus 5 equals -1. Now look at this. I now have a single equation, but I only have one variable. Right? So here I can just directly solve. So I get x plus 6x minus 15 equals -1. I get 7x minus 15 equals -1. And then I get 7x equals 14 and x equals 2. And now that I have x equals 2, I can go back to either one of my original equations, okay? And I'm going to take 2, and I probably would plug it into equation 1. Just because it looks a little easier, but you can plug it into either one. So at this point, why don't you stop the video, take 2, plug it in, and let's see what we get, and we'll see our answer on the back end. All right, hopefully you plugged in. I got y equals -1. If you did not get -1, you might want to double check your work. And we'll see, but the proper way to write the answer would be as an ordered pair. So your final answer would look like 2, -1. All right. So let's do the next method. The next method is called elimination. And The next method is actually a little bit better when you have coefficients on all of your variables. So for example, if I had like 5x minus 2y equals negative 15, or let's see, 3x plus 8y equals 37. You realistically could do substitution. If I wanted to do substitution, I probably would take equation number 1 and solve for y. Now, that's going to take a little bit of work. Not too much work, but just enough that it could be slightly annoying, that I would rather at this point do what we call elimination. All right. So there are a couple of options of things that we can do with this. All right. All right. Number 1, we can multiply an equation by a non-zero constant. So for example, like if I were looking at this particular one, I would multiply equation 1 by 4, and I will discuss why I would do that in just a minute. All right. The second thing we can do is we can interchange the two equations. We can So for example, just because I labeled it 1 and 2 doesn't mean I couldn't switch the numbers and label the bottom one 1 and the top one 2. And the third thing we're going to do is we're going to add the two equations together. All right. And it's numbers 1 and 3 that you're going to do most often. All right. So you're going to multiply by a non-zero constant and you're going to add the two equations together. Now, if I multiply number 1 times 4, I'm multiplying each term times 4. So 4 times 5x is 20x. 4 times negative 2y is negative 8y. And 4 times negative 15 is negative 60. And I'm keeping equation number 2 the same. So 3x plus 8y equals 37. All right, now I want to add the two equations together. All right. Now the reason I multiplied was to get my y's to look like this. I've got negative 8y and positive 8y. Well, they add up to 0. But my x's add up to 23x, and it equals not negative 27, negative 23. All right, so x equals negative 1. Now you can take this negative 1 and plug it back into either one of the original equations. All right, so at this point, why don't you pause the video, plug it in, and let's see what our solution is. All right, so the answer I got was y equals 5. So you would write your solution as an ordered pair, negative 1, 5. If you wanted to check your work, you would take negative 1, 5 and run them through the original two equations. If it makes it a true statement, then your work is complete. All right? So now it's just a matter of practice. Those are the two ideal methods for this class that you're using. There's a third method called graphing, which graphing is an ideal method if you have a graphing calculator, but for our purposes, we don't. So we're going to focus on substitution and elimination. All right, so I'm going to give you two equations, 3x plus y equals 6. 6x plus 2y equals 12. All right, so there's the first equation. And let's try solving it, let's say by elimination, and see what we can think up. All right, So let's pause the video. I'll give you a little bit of a head start. I'll catch up with you on the back end. Okay, so the first thing I would do is I would multiply equation 2 by negative 1/2. So I would get 3x plus y, that's not a y, 3x plus y equals 6. And then if I multiplied everything times negative 1/2, I would get negative 3x minus y equals negative 6. Now when I add them together, 3x minus 3x is 0, y minus y is 0, so I get 0 equals 0. This is a true statement, but it's certainly a confusing one. If you get a statement like this, 0 equals 0, 8 equals 8, 10 equals 10, anything like that, it means that there are infinitely many solutions, all right? So I would write and just leave it like that. You can use something called parametric equations to get a more exact solution. I'm not into that. Just write infinitely many solutions, and I'm okay with that. All right. So let's try one more computational example, and then I want to get into just one application problem. Here we go. It's going to be very similar, but a little different. 3x plus y equals 6. 6x plus 2y equals 20. All right. So if you wanted to do this by substitution, I would take equation 1 and say y equals negative 3x plus 6. Then we can take that, plug it in for y. So I get 6x plus 2 times negative 3x plus 6 equals 20. 6x plus negative 6x plus 12 equals 20. And 6x plus negative 6x is 0, so I get 12 equals 2. Well, kind of looked like it was going the way the last one went, but unfortunately our statement's not true. At no point ever does 12 equal 2. Right? As far as I know. Or actually 12 equals 20 is better. But either way, it's still not a true statement. So if it's not a true statement, you can say there are no solutions. Lines are parallel. All right, and this is the way it's going to go. Doesn't matter what the statement is. For example, this 12 equals 20 could be 0 equals 8. Anytime you have something, right, if you just subtract the 12 from both sides. Anytime you have any sort of not true statement, it means that the beginning two equations, if you were to graph them, would graph as parallel lines. All right, I do want to keep you for just one more. All right. Applications are very important when you're talking about systems of equations. If you're watching this video for a class, I would almost expect some sort of application on a quiz or an exam. All right, so let's try this one. Last year, Mrs. Rogers invested $40,000. Part was invested at 6%. The rest was invested in a more risky venture at 10% per year. Combined income for the year totaled $3,120. How much did she invest at each rate? All right, so this is a fairly typical problem. I use the setting of money, but the setting could be a mixture of chemicals, a mixture of coffee. There's a variety of different settings it could be. But overall, these problems usually take about the same shape. So the first thing I want to do is declare my variables. I'm going to say, well, I'm going to use a different color just to get a little contrast. I like green. So I can say x equals the amount at 6%. right? And y equals the amount invested at 10%. So the first equation is pretty basic, right? We had $40,000 to invest, so I could say x plus y equals 40,000, right? I invested x at 6%, y at 10%, x plus y has got to equal $40,000. But now I need a second equation. Well, now I'm going to use my 6 and my 10% to my advantage. All right, so I'm going to, again, use a different color. So I'm going to say if I took x and I multiplied it times 6% as a decimal 0.06, right? That would be, now it would be the amount of money made, right? I got that amount, right? At 6% interest would get me that. So plus, again, 10% is 0.1 y, and the amount made for the year was 3,120. The hardest part about these problems is finding the two equations. So this is one area where I would definitely suggest practicing. If you're having any trouble, I would definitely ask for some guidance because it could really be helpful. All right, so now the problem is how do you do it? Well, you could do it either way. If you wanted to take the first equation, solve it for x or y, you could. I'm going to use the elimination method just because I want to. So I'm going to change the color. I'm going to rewrite. And 0.06x plus 0.1 y equals 3,120. And I'm going to multiply the top equation times -6 and the bottom equation times 100. All right, so why don't you at this point pause the video, multiply the two equations, and then we'll see where we're at on the backside. All right, hopefully you paused the video, took the time to multiply the equations. If you did, you would get -6x minus 6y equals -240,000. And you multiplied the second equation times 100. I got 6x plus 10y equals 312,000. Now, the thing that I'm looking for anytime I'm doing elimination is I'm looking for this kind of relationship. I'm looking for 6x, -6x. If we go back up here for just a second, I did this by substitution here. I did this one by elimination, right? I multiplied times -1/2. I got positive y and negative y because when you add them together, right, if you have the opposite numbers, you're going to always add to 0, all right? So when I add these two together, I wind up with 4y, and that equals negative, is it $72,000? And then divide by 4, and I get y equals, not -72, excuse me, just $72,000. I got 18,000, so definitely check my work. So what you can do now is you take that y, plug it back into either one of the originals. I would pick the first one. X plus y equals 40,000. Seems really easy, right? So why don't you pause the video, plug 18,000 in for y, and let's solve for x. All right. So I get x plus 18,000 equals 40,000. And I'm going to subtract 18,000. I got $22,000. And for my taste, I like to give that last sentence Mrs. Rogers invested $22,000 at 6% and $18,000 at 10%. And again, this just connects it back to the context of the problem. All right, there is a lot more practice to go, but I hope you got a good understanding of systems of equations, and I'll see you guys next time. Thank you.